just check the subscription billing pattern. As you know what subscription is, it's just a case where you subscribe for something for a particular period of time which gives you access to particular features from an app. So in Web 2, as you know, you just use a billing platform like Stripe or PayPal and pay for the subscription. This third subscription credential and charges the customer based on the schedule, whether monthly or yearly. But in Web3, the way this works is that when you run the subscription, this creates a PDA, a program derived account, as you know, that will record your subscription start time, the duration for which it lasts, and the price which you paid. Then when the subscriber keeps calling, and when the subscriber keeps calling subscribe, the merchant clears the payment and just keeps checking through the expiration date and your current payment, and be giving you access to such a maybe the resource. So let me show you what I mean here. For example, now the user transfers so to the program vault and the PDA. The PDA updates the program vault updates the expiry for the PDA. The PDA will now be checking your status of that your wallet in your account, which is your wallet or your PDA, and verifying the expiration date to know if you are paid and when your payment is going to end. And the protected service just keeps going around checking the PDA for this and keep granting the user access based on if the expiration date is not yet expired. So it will just keep checking continuously, as you can see, then be granting access based on every time it's checking. Yeah, so that's how it works on Solana. So some of the constraints here are amnesty time. So this access will rely on Solana's clock and a network-wide consensus, which sometimes would be accurate, but maybe it could drift from the normal world clock time, and it might add a grace period or might reduce your time depending on what happens. So in this case, developers should just add a small grace period in the logic to avoid cases like this. This is user-centric PDA. So each subscriber has much a unique PDA derived from transfer. This allows to verify user status with common complexity, as the account address can be calculated locally by a client without searching a database. Oh yes, this is nice, but this just shows another issue that if the program should go down or something, this subscription will automatically end with no way to retrieve it from the database or anything like that. Let's look at the trade-off. The trade-off is, instead of the classic pull model, you are now using a push and prepaid model, because this must proactively renew their status instead of just pulling, which can stop cases of someone pulling your that's Web2 pulling your funds, which happens to a lot of people. Maybe you forget to close your subscription and they just pull it automatically. But so now you need to verify each action that is being taken on your account. So yeah, the gating logic is by a private server database, so the verification will be internal and not audited by the user itself. But this is the verification here is cryptographic, instant, and visible to all, meaning nothing changes. I can keep monitoring the program on the devnet if it's available to you. Instead of cron jobs as done here, this one just relies on the external network keepers and cracks that are incentivized to trigger renewals. In this case, this just shows that you could use like dedicated servers to run cron jobs, but in Solana case use creepers or cracks. But Solana is less cheaper for running this than on Web 2. So this is the native code, you can check it out, and this is the test. So this is just the test, this is just a live UI. So in this case now, this is standard code, you have default access, but you don't have access to this resource. So let's buy 60-second access just for test. In this case, just network issue. Yeah, that's a network issue. So as you can see, the subscription has been secured for 60 seconds. Now you can just check on-chain verification to verify that this is the on-chain verification that happens. So normally this is automated, but we'll do it here in this case. Now, as you can see, you can just be accessing this on-chain verification. You can just be accessing, so the resource here is on-chain verification, like the public resource that is close to others here is on-chain verification. As you can see, when you tried it, it worked because you have access for 16 seconds. You can actively cancel your subscription maybe in a trial grace period. And yeah, so that's just testing. So as you can notice, once the time closes, your access to the app will be locked, as you can notice here. So that was just how Solana does it, active checking and stuff like that. So as you can see, it's working.